Why were they probably what is talking art?
All right, young scholars, we have some tasks to complete today. Basically, what we're going to review today is very similar to what we've talked about 2 weeks ago. As you saw when you watched the recording for Tuesday's lecture, it's basically similar to what we touched on with lists, stacks, queues, priority queues. So since there's no programming assignment, the last one was due on Monday evening, we're just going to walk through, for example, programming assignments, and then I'm going to review the remaining 2 course assignments for the semester. So again, hopefully you went and watched that recording related to the implementation. But like I said, we've seen this previously from 2 weeks ago. So first, I'm going to create a new class called List Exam. And I already have one from 2 weeks ago. So I'll call this one List Example with an S at the end. So if you remember, when we're using a list, we need to import array list and just regular list. Then I create my class. And my method. So who remembers what needs to be done first within our method? We're creating a list. What do we have to do? What's the first thing I need to do? Maybe this will help. Does the comment help? What's the first thing I need to do? I have to create my array list. Yep, create our array. So we're going to set it up as strings. What should we call this? Well, first, what do we want to put in this string list array? Names, animals, characters.
How do you spell
Name.
Names, okay. So let's call it, students. And we'll just put our names in. So then we need to do new array list, the less than and greater than, then our parentheses. So who remembers from 2 weeks ago how we add items into our array list? No one?
We have to put what we want to add, and then
Yep.
put add.
So we take the name of our array, students, and then dot add. So we have that dot add is our function. So let's add 5 student names. So here we're now adding 5 student names. So let's say we put in Grace, Amelia, Franny, Zaza, and Lana. But then what we have to do, what's the last thing we need to do now that we've created our list? How do we display this to the user? Everybody's so talkative today. We have to do a print line. Whatever our message is to the individual looking at the screen, plus our array list. So what message do we want to give? These are students in CPM 226.
Or gaming things. The characters are the president.
So if we go ahead and compile and run that, it'll now say the students of CMP 226, Grace, Amelia, Franny, Zaza, Lana. So maybe I'll add R at the end. Then we run. We see here the students of CMP 226R. I forgot Calvin. I did on purpose, Calvin, because I want to show you guys something. So you get that message that comes up. So if we go back in here and we do students.remove Calvin, what's going to happen?
Big one.
What's going to happen?
It's gonna remove the name.
It's going to remove the name Calvin?
I want a big.
Oh, we don't have Calvin yet.
I want big.
Oh no, nothing's gonna happen.
So we go ahead and compile and run.
After synchronous windows. And how do you know what it looks like?
And absolutely nothing happened. We get the same output. But if we go ahead and add in Calvin and then comment out that remove, compile, and then run. Now Calvin is added to the array list. But
Yeah.
if we go back in
Incredible the game.
to get rid of the comments and compile, now what's going to happen?
He's gonna remove Calvin.
Yep. Now when we compile and run that, it's going to go back to what we had initially. Calvin is now removed. So your remove function is only going to work if you have added. Well, in this case, a name, because we are set up as a strings. For example, we've added Calvin now. Now we're going to remove Albert. So we compile and run. And we go back to that now array list where Calvin is back in. Because Calvin's not being removed. Albert is being removed, but Albert is not in the array list. So nothing really happened. Removing string that is not in the array. So nothing occurs. So hopefully, since we've done this twice now with our array lists, that it's kind of sitting in. And it's the same thing whether you have a string, an int, a double, etc. You would simply have your parameter in place here. So instead of in a quote, you would have your integer, let's say 27 would be there. And again, with all of the others, I'll post these up on Blackboard when we're finished. So next I'm going to do stack example. I'll add an S at the end of this one, since we already had a stack example from 2 weeks ago. For a stack, we import java.util.stack. Then I set up my public class. Then I have to set up my method. So what's the first thing we need to do in order to put items into our stack? Same as we did with our list. We have to create it first. Yep. So it's stack. And then in the less than greater than, it's going to be string, because we're going to do a string again. What do we want to put here? Let's do letter grade. So we'll call it grade. Now we do the same as we did with the array. but we use the term stack instead because we're creating a stack. So it's stack, our parameter is string, our name is grades, and we're setting up the new stack.
Chris, could I have a couple pieces of scrap paper and a pen?
Need to
Somebody asked you.
add the parameters to our stack. So who remembers, is it add and remove like it is for a list? What is the function we do to add for a stack? Who remembers? What's another?
It's push.
Yep, push. So we have to take that array name of grades and then do dot push instead of dot add. So let's say the first grade is A, second grade is B, third grade is C, fourth grade is D. Nope, not E. Fifth grade will be F. So now, if we wanted to print them out, system.out.println. Let's say potential grades in CMP 226 are, and then we need to add the name of our array list, or the stack in this instance. So we print out a message to the user and we compile. It'll say potential grades in CMP 226R. And then it would be A, B, C, D, F. So we go ahead and compile and run potential grades in CMP 226R. But what is the remove in stacks? Do you remember? Push is the same as add. What is the opposite of push?
Pull.
Pull.
Pull? Is that right? Is that what our remove is? Amelia, help them out. You knew the push. Do you know the opposite for the remove? You remember from 2 weeks ago? Where is it? The opposite is pop. So add and remove, push and pop. So if we wanted to say that, hey, you know, everybody's going to pass. Oops. we would pop. Why doesn't it like me?
Oh, sure.
I see. So that's an error on my part. So with a stack, when you pop out, you're going to pop them out one at a time. So instead of doing this print line the way we did it, we would potentially do grades.pop there. So this way, as it prints each one out, it would remove them. So next we're going to do another QE example. So I'll call this QE example with an S so that it doesn't interact with the one we did 2 weeks ago. With a QE, we're going to import linked list again. And also our QE package. Then I need to create my class. And hopefully I spelled it the same way again. And then create a method. First, I need to create a QE. And I have to add items to it. So just like our array list and stack, we start with QE. We're going to keep the theme going of strings. And what do we want to put in this QE? Do we want to, let's do names again for the students. And since a QE is in essence a linked list, we have to do names equals new linked list, matching the greater than and less than to pass our string, and then the parameters for the function. So when you are using a QE, you can use add, remove, or QE and DQE. But to make things interesting or easier, I'm just going to do the add version. So we add in all of the student names. Lana, Zaza, Franny, Calvin, Grace, and Amelia. So when we print this out, what order is this going to be in? What order are these names going to be in?
In order?
In this exact order. that I have them. Lana, Zaza, Franny, Calvin, Grace, Amelia. Because it's a regular QE, they'll just be printed out in the order they're listed here.
Yeah.
So what message do we want to display?
Keep an exchange. Please keep this.
Just the students of class again? Program class names, okay? So that's in quotes, and then plus our QE name, which is names. So if we compile and run that, we now have all of our users displayed, everyone we inputted. Who are we forgetting? Isn't there 7 young scholars in class? Who am I forgetting, Franny? Al? I think I'm forgetting Al. So if we went in, added Al, we now have everybody in class. Compile and run. And Al is just added on at the end now. So the QE, like I mentioned to you guys, it's like a to-do list or a shopping list where it's literally just in the order you write everything down. So that's what the output ended up as. Lana, Zaza, Franny, all in order. And they're displayed just in that QE, just like they were in the stack and in the array list.
Yeah. Especially now I know you're doing some.
So now we're going to create, lastly, a priority QE. So I'll call this PQ example.
Another dollar. Good. Okay. Let's get through that.
And the import for a priority QE, as you saw 2 weeks ago, is that import java.util.priority QE. Assuming I spelled that correctly. So then I create my class. And then I create my method. What's the first thing I need to do? I have to create my priority QE and add elements to it. So it's priority QE. And I'm going to do string again. We'll do the same thing. We'll have students. And then we do equals new priority QE. So notice each one of them has the different way to create them. The priority QE is priority QE. QE is just QE. Stack is stack. Whereas the list is list but is created as a new array list. And like I said, with a QE and priority QE, you can either add using add, or you could use QE. And to remove, you could use remove or DQE. But to make it simpler, I'm just going to use add and remove again. So we would have to do students dot add, because students is the name of our priority QE, and add is the function we use in this instance.
I have to put in that last dollar. It's on one. Yeah. Put in the last.
So Zaza, Amelia,
Oh, no.
Grace, Al, Franny, Calvin, and Lana. Then we have to print it out. So system dot out dot print line.
The original is on top.
We'll do young scholars in CMP 226. Then we have to add our QE. So that students. So plus students. So now I'm going to compile this. What's going to happen when I print this out? What order is it going to be in? And you'll notice we saw this 2 weeks ago. Keep this in mind when you're answering. What's going to happen with this printout?
Wasn't it the capital names first and then the lowercase?
I think so. It might have been the opposite, but it's going to group the lowercase ones together and the capital ones together and put them in ascending order. So Al, Calvin, and Grace are lowercase. It would be Al, Calvin, Grace. Zaza, Amelia, Franny, Lana are uppercase. So that would be Amelia, Franny, Lana, and then Zaza. Let's compile and run that just to remind everybody which one was first, whether it was lowercase or uppercase. Okay, so it gave us it in the exact order that we put it in as. How come? We didn't do our DQE. Did I spell it wrong? Oops. Where is it? We're going to output it as students.poll. And now if we run it, it should run correctly. No, now it's just giving us Amelia's name. So what we're going to do
It's because
instead
it likes
of,
me best.
it's possible. Instead of add, we're going to do offer. For priority QE, it might only like add for integers. So we're going to change all of our .add functions to .offer function. And now we'll try it again. The joys of live class, ladies and gentlemen. And it still only gives us Amelia. Apparently, it's Amelia's world and we're all just living in it.
Yeah, this is true. I am the main character.
So we'll add a while loop to pull out all the names. So while what did we call this? Students. So exclamation point students. That is empty. And then put your open bracket after the while loop and the closing bracket after the printout. Errors? Where are the errors? It doesn't show me an error. Ah, I see. And we need an extra bracket there. One to close our method, one to close our class, and one to close our while loop. Then we rerun. Hopefully now it actually works the way it's supposed to. There we go. So you got Amelia, Franny, Lana, Zaza, Al, Calvin, Grace. So it did uppercase first and then lowercase. So that's what you said, Grace, right? So
Yeah.
Grace remembered that. She was correct. Awesome. So if we wanted all of the names in exact alphabetical order, what we would have to do is make them all the same case. So now they're all uppercase. We compile. Al should be first, then Calvin, then Amelia, then Grace, then Franny. Nope, Franny would be before Grace. Sorry. Then Lana. Then last but not least would be Zaza. So then we compile and run that. Should be in alphabetical order. Yep. Al, Calvin, Amelia, Franny, Grace, Lana, Zaza. So before, without that while loop with the poll, we were just printing out the first item of our priority queuing, which was back when we had Al, Calvin, and Grace. At lowercase, it was Amelia, because she was the first uppercase student in the list. Okay. So first, I'm going to add all these examples up into Blackboard. And sample code, I believe, is what I've been calling these folders. Make it visible. Everybody wants to see and enjoy these nice, fun Java programming examples. So first we had the list example. And make it visible so everybody can see it. Okay, so that was the list example. Next we have the stack example. We'll make that visible. Okay. Then we're going to have the QE example.
Yeah, that's so great. Oh, Josh from Wild Mills. Yeah, he's really good on
And last, I'm going to upload the priority QE example.
That's what I was like, but it could be like the older kid. I'll say it again. A great one. Just get out there. Oh, yeah. I think you just find out from him. What age he wants to on this. Or he wants to hear the picture, he wants to. That might be like a good family project.
All right. So now, last but not least today, I want to go through the remainder of the course and what's going on. So all 4 of those examples we just went through are uploaded in this week's folder up in the sample code. As always, I'll pop in the recording once it's finished up on YouTube. I didn't include other YouTube links because, like I said, we primarily covered basically the same exact stuff. 2 weeks ago, the only major difference is we used primarily integers that day, and today we used primarily strings. So going forward, you'll notice there's only 3 folders left here. So next week, on Tuesday, we're going to cover a lecture on binary search trees and AVL trees. Then in class on Thursday, we're just going to go through one programming exercise of search trees and one of AVL trees, because it requires quite a bit of code to go through and utilize those. So there's just going to be one example of each rather than, as you've seen in all the previous Thursday sessions, where it's usually 4 or 5 programs we go through. You'll notice in that folder that there is a take-home exam that isn't due until the 4th. So that's the first thing I wanted to ask everybody. Would it matter if I opened it to everybody today or wait until next Thursday when we cover everything? You could just vote in the chat, hey, today, open it today. If I opened it today, you'd have, in essence, an extra week to do it. But, you may have other classes where other things you need to worry about. So you may not want to start on it early. It's up to you. So in the chat, write either today if you would be okay with opening it today, or next Thursday, if you have other things going on, you don't really want to worry about this. Like I said, the big difference would be if I open it today, you have an extra week to do it. So,
Depends on where, we could do it at any time. Some of our actually, most of my planners for the summer, I think, is 30.
so if I opened it today, what would that be? 21. You'd have like 25 days to do it.
You know, it's-
Nope.
You're just gonna open it.
Is this timed? Like if you open it, will it continue to count the time when you save and do it again?
No, you're just asked to do 3 programs.
Okay, then I think open it today. I think that's probably the best case.
So I'll go ahead and show you what is required of you. So you're basically, in essence, just writing 3 Java programs based on what we've used in class so far. Or, well, basically what you're going to learn in class the entire semester. Because when we cover trees next week, you'll see trees in data structures. If you go on to basically the 3rd programming course is called data structures, trees will definitely be discussed there. So for your first question, it's combining arrays and exception handling. You're going to write a Java program that prompts the user to input 5 integers and stores them in an array. So that's the array part. But you have to ensure that the program handles exceptions if the user enters non-integer values, which is the exception handling part. Then find and print the sum of the integers entered. So you'd have to go back to when we covered arrays initially, and you'd have to go back to the exception handling section that we covered and look at your input mismatch example and basically kind of combine them together to get your programming question answered there. So question 2 combines classes, inheritance, and polymorphism. So you're asked to create a Java program that models a simple banking system. Define a bank account class with attributes account number and balance, and then implement 2 subclasses, checking account and saving account, both that are inheriting from bank account. Implement a method called withdraw in each subclass to deduct money from the account. Demonstrate the use of polymorphism by creating instances of both subclasses and calling the withdraw method. So we did that when we covered interfaces and abstract classes. We did that when we covered inheritance and polymorphism as well. So you have about 2 weeks of information to go through for that. Whereas exception handling, it was just 1 week. Arrays was just 1 week. For all of this, you can refer back to inheritance and polymorphism, as well as interfaces and abstract classes. And then the last question combines lists and recursion. So you're asked to write a Java program that uses recursion to find the factorial of a given integer using a custom calculate factorial method. Additionally, use a list to store the factorial values of each intermediate step. Finally, print both the value and the list of all of the steps.
That's 2 more than I.
So that's going to combine what we've basically been doing the last couple weeks with the concepts we covered the week we covered recursion. So I'm going to open that now. So it's not going to be due until December 4th. What is that? A Monday evening, I'm assuming. So basically 3 weeks from Monday, I guess that is. So you're more than welcome to submit it early. Keep in mind, if you submit it early, there's a chance that I will grade it early though. So that is now up. So then the week after next week. The 20 or the 21st and the 23rd. So the 23rd is Thanksgiving. So like I said, I gave you guys that Tuesday off. I didn't assume anybody was really going to show up anyway, might have gone home, might have other things you needed to accomplish before you head home for Thanksgiving break. So I gave you guys that entire week off. Then the week after that, the 28th through the 30th, you're going to have it set up where I'm going to have a Zoom option for you guys to pop in and ask questions about the group project. But basically, you're going to meet with your groups. So Amelia and Grace were one group, I'm pretty sure. So basically, you'd meet that Tuesday and Thursday, make sure everything's done for your group project. So, you may pop in and ask a question. You may not have a question. So, just kind of work with your teammates that week, your group members, and make sure you have everything, your code ready to submit here for the group project that
Okay.
is also due on the 4th. So all you're submitting for group project is your code. Like I said, your presentation, that 20-minute presentation you'll do the following week. You don't need to have any kind of slides or PowerPoint or anything. You're just going to talk about why you chose Hangman or Tic-Tac-Toe, how you created it, how long it took you, who did what section, and you're going to provide a demonstration. So like I told you, it's 20 minutes.
Thanks for
So obviously, if you're doing the Hangman game, the demonstration is going to take more time than the tic-tac-toe game. The tic-tac-toe game you could play in 2 minutes. The Hangman game might take, let's say, 7 minutes. So go ahead and make sure that beforehand you kind of practice your demonstration, see how long it's going to take, and then plan the rest of your presentation around that. So say your Hangman game takes 8 minutes. Then you only have to fill in 12 other minutes with your discussion on the other concepts here. Whereas if you had the tic-tac-toe game and your demonstration takes, let's say, 3 minutes, you have to fill in the other 17 minutes with the remainder of your discussion. So are there any questions on that? No? Okay. So again, that week after Thanksgiving, I will have Zoom set up. You can pop in and ask a question as you need to. But, you don't have to pop in. You might not have a question. So that would be fine. And then the following week after that, on the 5th, that Tuesday, we'll have all 3 of the presentations. And then that Thursday, the 7th, if anybody needs to, we'll have some kind of extra credit possibility available. So let's see, what are the groups again? Zaza and Franny is one group. Amelia and Grace is one group. And Lana, Al, and Calvin is the other group. So again, that week after Thanksgiving, what is it? 11, 28, and 30. You and your group members would basically meet on those days and basically make sure that everything's done. Prep your presentation, make sure your code runs, see how long the demonstration of it would take, those type of things. And like I said, I'll be here on Zoom. You don't have to attend if you don't have a question. You could just pop in and ask your question as you need to. And as I pointed out a while ago, there's examples here. You literally click on a YouTube and it will show you how to do these games in programming. So there's a link for how to build a hangman game. There's a link for how to build a tic-tac-toe game. You don't have to use those. Like I said at the beginning of the semester, there's many of these available online if you just simply Google it. But like I said, your hangman game is, more involved. It's going to take longer to demonstrate. So that might be, as you see as part of the presentation, why you chose the game. That might be one of your reasons. Hey, I chose the hangman game because the demonstration was going to take longer. I don't really like public speaking. It could be something that simple, but obviously add on to it so that you're going to meet the 20-minute presentation time. So are there any questions on that? Again, we're getting into the long and the short of it, as they say, the last couple weeks of the semester here. So so if there are no questions on that, I will see everybody next Tuesday, where we're going to discuss those
Professor, I got a
final
question.
fees. Okay, go ahead.
I wanted to know, can I make up the assignments that I was missing? 2 assignments.
Who is iPhone? Al?
Yes.
What assignments did you miss?
Let me see. I missed the last assignment, and I did not like my grade on. Let me look. I'm looking. On homework 5, 10, and homework 8. I didn't like my grade for homework 8.
You didn't like your grade for homework 8?
Yeah.
How come? Was it
I
bad?
got a 50%.
Okay. So I'll let you make up the last one, 10. Just email me when you're finished, but focus more on that take home and the group project, because those two combined are 70% of the grade.
Say that
So
again?
the take home exam and the group project,
Yes.
they're 70% of the grade. So I
Okay.
want you to focus more on making sure you do well on them. So this way you're in good shape for the class. Do I even have,
Because I really need an A for this class. So
let me
you think
see.
I could get
Do
an
I
A for
mention
this
on
class?
the course syllabus? What is an A? 90? 94. So let's say you had ended up with like a 93.5. I would round that up to a 94. So you'd be in good shape, because each of these assignments was only 3%.
Okay.
So if you only had 2 low scores, you're still in great shape.
Okay.
So just make sure you get that assignment 10 in.
Okay.
All right. Does anybody else have any questions going forward?
Thank you.
No problem. No? All right. I bid everybody adieu, and I will see you next Tuesday.
Bye, Professor. Have a good one.
Take care.
Bye.